Okay, the factor theorem. According to the factor theorem, okay, some number is a zero or x-intercept or root of f of x, if and only if x minus k is a factor of f of x. So what we want to do is we want to show that we're given a divisor here, x plus 2. We want to show that this factor, that this actually is a factor of this function, x cubed minus 6x squared minus x plus 30. And then after that, we're going to factor this completely, find all the remaining factors, and use these factors to pick out zeros of this polynomial. Okay, so they point us in the right direction from the very beginning, that they want us to test x plus 2 to see if it's actually a factor, or to show that it's a factor. So what I'm going to do on this is I'm going to use -2 out in front and use synthetic division for this. So with synthetic division, I'm going to pick out the coefficients for our function here that we're trying to divide by x plus 2. And I used positive 2 because I want to know when this factor is equal to 0, or when this divisor is equal to 0. So x plus 2, when that equals 0, we're using an x value of -2. So our coefficients go up above: 1, -6, -1, and 30. We didn't skip any powers of x, by the way. X to the third, x squared, x to the first, x to the 0 power. So I didn't need any placeholders up above. Okay, so next, for synthetic division, the 1's going to come down, and then we multiply. -2 times 1 makes -2, and add. -6 plus -2 makes -8. Multiply. -2 times -8 makes +16. Add. -1 plus 16 makes 15. Multiply. -2 times 15 makes -30. And then when we add, we get a 0. All right, that's what we're looking for. That's it, the indication that x plus 2 works as being a factor. All right, whenever we get a remainder of 0. All right, that's going to be a big key as we go through this. All right, now let's see if we can rewrite this. The dividend, that's this function here, the x cubed minus 6x squared minus x plus 30, that's going on this side, equals our divisor. Well, we just divided by x plus 2 times the quotient. Well, the quotient, if you understand how to read it, is given by these coefficients that are down below here. So remember, right next to the remainder, this 15 is going to be a constant. And then the next digit is going to be an x to the first. The next one's going to be an x to the second. If we had more digits out here, you just keep counting up on the powers of x. So we can rewrite this quotient as x squared, 1x squared minus 8x plus 15. And then our remainder, we could tack on a plus 0 here as our remainder, or we really don't have to add 0 to the end of this. All right, to finish this up and complete our factoring, let's see if we can factor that second degree polynomial inside the second set of parentheses. So in this case, I'm going to bring along the x plus 2. And I think this is going to work out pretty nicely, that we can say x and x for the x squared, 3 and 5 to make the 15. If we make them both negative, they'll add together and make this -8. All right, so we factored it completely. Now, so let me label this. This is the factored form, factored completely. And now let's pick out all the zeros. So the 0 that goes along with the factor of x plus 2 is going to be -2. Kind of visualize, what would I need to plug in for this x and this factor to make this factor equal 0? So -2 plus 2 makes 0. In the second factor here, we can say +3 minus 3 makes 0. And the last factor, we can say +5 minus 5 makes that equal 0. If you have trouble with any of these, just set them equal to 0 off to the side and solve down, and you can get these zeros. All right, let's work through one more of these in this, this video. Trying to use this factor theorem to find all the zeros of f of x equals x cubed plus 4x squared minus 4x minus 16, given that x minus 2 is going to be a factor of this polynomial. So they push us in the right direction here by saying, hey, why don't you use x minus 2? So when we're doing this, we're dividing by x minus 2, so +2 is going to go out in front. And then steal the coefficients, so 1, 4, -4, -16. 1 comes down, we multiply, add, multiply, add, multiply, add. Okay, so again, we got to a remainder of 0, which is good. So we can say we just divided by x minus 2, because we used +2 out in front. Now our quotient is going to be these values over here go as coefficients. So again, it's constant, x to the first, x squared. So we can say 1x squared plus 6x plus 8, and then plus a remainder of 0. So we don't really need to include that remainder of 0. A little bit more factoring that we can do in this case. I think we should be able to factor that second degree polynomial by hand at this point. So we have x and x to make the x squared, 2 and 4 to make the 8, and this is going to have to be both positive to make a positive 6x in the middle. All right, so again, that's factored form. We factored that polynomial completely, f of x, and now let's list out all of the zeros. So remember, that's just whenever this factor equals 0, what would I need to plug in for x? So in this case, positive 2 for the first factor, as I wrote it, negative 2 for the next one, and negative 4 for the last one. So we found all the zeros of this polynomial and factored it completely. All right, hope this helps out as you're working on synthetic division and trying to factor polynomial functions. Good luck to you.